Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. I hope you all are fine. I am Amina Sadiq, working as subject specialist in mathematics at Divisional Public School and College Sahiwal. Today, we are going to discuss about roots and the coefficients of a quadratic equation. We have started this topic in our previous lecture. Today, we will complete exercise 2.3, question number 4, 5 and 6. So recalling some concepts from the previous lecture, what is the root of the quadratic equation? The quadratic equation ax square plus bx plus c equal to 0 has two roots. We know that the quadratic equation ax square plus bx plus c equal to 0 has two roots. One is minus b plus square root of b square minus 4ac over 2a, and the second is minus b minus square root of b square minus 4ac over 2a, where a, b and c are real numbers and a is not equal to 0. For simplicity or for the convenience, let us call these roots as alpha and beta. If one is called the alpha, then the other is called beta. The relationship between roots and the coefficients of the quadratic equation can be explained by the sum and the product. So the sum of roots, that is alpha plus beta, is equal to, we put the value of alpha and the value of beta. On taking the LCM, we get minus b plus square root of b square minus 4ac minus b minus square root of b square minus 4ac over 2a. The terms with the square root will cancel each other and the remaining terms are added, minus 2b over 2a. After cancellation, we get alpha plus beta equal to minus b over a. So the sum of roots alpha and beta is equal to minus b over a. Minus b is the coefficient of x and a is the coefficient of x square, or b is the coefficient of the linear term and a is the coefficient of the quadratic term. Similarly, for the product of roots alpha and beta, we put the value of alpha and the value of beta, then we multiply them. Minus b plus square root of b square minus 4ac and minus b minus square root of b square minus 4ac are the conjugates of each other. Or we can use the identity for the squares. After using the identity, we get b square minus 4ac over 4a square. On solving, removing the bracket and simplifying it, we get 4ac over 4a square. After cancellation, we get alpha beta is equal to c over a, or the product of roots alpha and beta is equal to c over a, where c is the constant term and a is the coefficient of x square. There are 5 procedures to find the unknown values involved in a given quadratic equation. The first is sum of all the roots is equal to the multiple of a product of these roots. We have already discussed two of them. The first one was if sum of all the roots is equal to a multiple of the product of the roots. The second case was sum of the squares of the root is equal to a given number. Today, we are going to discuss the third case, when two roots differ by a given number. Let's explain it by the help of a question. The question states, find p. You have to find the value of p if the roots of the equation x square minus x plus p square is equal to 0 differ by unity. The roots are differed by unity. It means if one root is alpha, then the other root should be 1 less than alpha. And we have to find the value of p square, which in this equation is a constant term. So let alpha and alpha minus 1 be the roots of the equation x square minus x plus p square equal to 0. We already know that the sum of the roots is equal to minus b over a, means the coefficient of x, and a the coefficient of x square. Putting the coefficient of x, that is minus 1, and putting the coefficient of x square, that is 1, we get alpha plus alpha means 2 alpha minus 1, and solving this we get 1. Taking this one from the left hand side to the right hand side, we get 1 plus 1, which is equal to 2. Dividing this equation by 2, we get alpha is equal to 1. Now, for the product of the roots alpha and alpha minus 1, we know that they are equal to c over a, where c is the constant term, which is p square here, and a is the coefficient of x square, which is 1. So, solving this we get p square. It means the roots when multiplied will be equal to p square. We know that alpha is equal to 1, so putting this value of alpha equal to 1 in this above equation, we get 1 times 1 minus 1 is equal to p square. This 1 and minus 1 cancel each other. 1 multiplied by 0 is 0, so p square is equal to 0. If we take the square root of this term, square root of 0 is always equal to 0. So, p is also equal to 0. So, in this case, the value of p is 0. The fourth case is when roots satisfy a given relation. This can also be explained with the help of a question. We have to find the value of m if the roots of the equation x square minus 7x plus 3m minus 5 equal to 0 satisfies the relation 3 times alpha plus 2 times beta is equal to 4. In this quadratic equation, x square is the quadratic term, minus 7x is the linear term, and 3m minus 5 is the constant term. By this given relation, we can understand that we have two roots, alpha and beta. So let's alpha and beta be the roots of the equation. X square minus 7x plus 3m minus 5 equal to 0. Then the sum of roots will be equal to alpha plus beta is equal to minus b over a, where b is equal to minus 7 and a is equal to 1. On simplifying, we get alpha plus beta is equal to 7. Or we can write it as beta is equal to 7 minus alpha. We call this equation 1. Now, the product of the roots is equal to alpha multiplied by beta is equal to c over a. Putting the values of the constant terms and the coefficient of x square, we get 3m minus 5. Or we can write it as the product of roots alpha and beta is equal to 3m minus 5. We call this equation 2. The relation given in the question 3a plus 2b is equal to 4. We call this relation equation 3. Putting the value of beta from equation 1 in equation 3, we get 3 times alpha plus 2 times, putting the value of beta, that is 7 minus alpha, equal to 4. We get 3 alpha plus 14 minus 2 times alpha equal to 4. On solving, we get alpha is equal to minus 10. Putting alpha equal to minus 10 in equation 1, we get the value of beta, which is equal to 7 minus 10, which is equal to 17. Putting these values of alpha and beta in equation 2, we get minus 10 multiplied by 17 equal to 3m minus 5. On solving, we get minus 70 is equal to 3m minus 5. Taking 5 from right hand side to the left hand side, we get minus 165 is equal to 3m. Dividing by 3, the value of m is minus 55. So, we can say that the value of m is minus 55. Let's solve another part of the same question. At this part, we have to find the value of m. If the roots of the equation 3x square minus 2x plus 7m plus 2 equal to 0 satisfy the relation 7 times alpha minus 3 times beta equals 18. As we can notice that alpha and beta are the roots of the equation 3x square minus 2x plus 7m plus 2 equal to 0. So, let alpha and beta be the roots of the equation given. Then, sum of the roots alpha plus beta should equal to minus b over a, putting the value of b, that is the coefficient of x, minus 2, and putting the value of a, that is the coefficient of the quadratic term, that is 3. We get alpha plus beta equal to 2 over 3. Then beta will be equal to 2 over 3 minus alpha. Let us call this equation 1. The product of the roots alpha and beta is equal to c over a. C means the constant terms, that is 7m plus 2, and a, the coefficient of the quadratic term, that is 3. So alpha beta is equal to 7m plus 2 over 3, and let's call this equation 2. Putting beta is equal to 2 over 3 minus alpha in equation 3, that is the relation 7 alpha minus 3 beta equal to 18, we get 7 alpha minus 3 times 2 over 3 minus alpha equal to 18. Solving this, we get 7 alpha minus 2 plus 3 alpha equals 18. Solving it for the value of alpha, we get alpha equal to 2. Putting this value of alpha equal to 2 in equation 1, that is beta is equal to 2 over 3 minus alpha. So beta is equal to 2 over 3 minus the value of alpha, that is 2. By taking the LCM, we get beta equal to minus 4 over 3. Now we put the value of alpha and beta in equation 2. 2 times minus 4 over 3 equals 7m plus 2 over 3. Multiplying this, solving this, we get minus 8 over 3 equals 7m plus 2 over 3. Simplifying it for the value of m, we get minus 10 equals 7m. So the value of m is minus 10 over 7. The last case is when both sum and the product of roots are equal to a given number. For this case, we have the question, find the value of m if sum and product of roots of the equation, this is the given equation, is equal to a given number lambda. It means the sum of roots, let the roots be alpha and beta, then their sum alpha plus beta should equal to lambda, and their product alpha multiplied by beta should also be equal to lambda, and lambda is any number. We have the equation 2m plus 3 times x square plus 7m minus 5 times x plus 3m minus 10 equal to 0. In this equation, the coefficient of x square, that is a, is equal to 2m plus 3. The coefficient of linear term x is equal to 7m minus 5, and the constant term is 3m minus 10. Let alpha and beta be the roots of the equation given 2m plus 3 times x square plus 7m minus 5 times x plus 3m minus 10 equal to 0. Then the sum of the roots alpha plus beta is equal to minus b over a, which is equal to minus 7m minus 5 over 2m plus 3 equal to lambda. We know that the sum of roots is equal to lambda, so we put all these values equal to lambda and call this equation 1. And the product alpha beta, which is equal to c over a, will be equal to the constant term 3m minus 10 over the coefficient of x square 2m plus 3, we call as given in the question. The product of the roots of the equation should equal to a given number lambda, so we put this equal to lambda and call this equation 2. Since these two equations are equal to lambda, then we can say that these two equations are also equal to each other. This is the transitive property. If a is equal to b and b is equal to c, then a and c are also equal. So we have minus 7m minus 5 over 2m plus 3 and 3m minus 10 over 2m plus 3. These two equations are equal to each other and they have the same denominator. By using the cancellation property, we can cancel 2m plus 3. By using the cancellation property for multiplication, we can cancel 2m plus 3 with 2m plus 3 and get minus 7m and get 5 minus 7m equal to 3m minus 10. These values change their sign because of this negative sign. On solving, we get 15 is equal to 10m, where m is equal to 3 by 2. So, the value of m is 3 by 2. Now, let's recapitulate our today's lecture. The quadratic equation ax square plus bx plus c equal to 0 has two roots. These two roots are minus b plus square root of b square minus 4ac over 2a and minus b minus square root of minus 4ac over 2a, where a, b and c are real numbers and a should not be equal to 0. For the simplicity or the convenience, we call these roots as alpha and beta. If one is called alpha, then other will automatically call beta. The sum of these two roots, alpha and beta, is always equal to minus b over a, where b is the coefficient of the linear term or x and a is the coefficient of quadratic term or a is the coefficient of x square. The product of the roots alpha and beta is equal to c over a, where c is the constant term and a is the coefficient of x square. To find the unknown values involved in a given quadratic equation, the following conditions can be used. The first one is sum of all the roots is equal to the multiple of the product of the roots. The second case is when sum of the squares of the roots is equal to a given number. The third case, which we have studied today, is two roots differ by a given number. The next is when roots satisfy a given relation. And the last case is when both sum and the product of the roots are equal to a given number. All these 5 cases helps us in finding the unknown values involved in a given quadratic equation, and they are very helpful in solving advanced level mathematical problems. This will also help us in the problems related to engineering and architecture. My dear students, this is all from our today's lecture. Now it's time for your home task. You have to complete the remaining parts of question number 4, 5 and 6 of exercise 2.3. You have to solve the examples 3, 4 and 5. My dear students, I hope you understand our today's lecture. If you want to ask some further questions, you can discuss it with your respective teachers. Stay safe, stay calm, and stay at home. Thank you and Allah Hafiz.